Okay, linear differential equations with with constant coefficients. Okay, higher order. This is actually, and today's date will be 24. So linear differential equations with constant coefficients. It will be higher order. In previous lectures, we have studied more briefly about first order differential equations. First of all, we have finished variable separable method. Mm, Then how to solve homogeneous differential equations. Okay. Then reducible to homogeneous differential equations of first order. Then linear differential equations of first order. Okay. And at last we have solved exact differential equations of first order and reducible to exact differential equations of the first order. That means there are 5 lectures on these topics of first order. Now from today we will start with higher order. Actually order is what? In differential equations, the number of derivatives, in the differential coefficients, the number of derivatives will indicate the order. Remember it. If the highest derivatives is 2, then order will be what? 2. If the highest derivatives in this differential coefficients will be 3, order will be 3. So highest differential of the coefficient will indicate the order. So remember it, order of these differential equations. Actually, we are studying about higher order differential equations, and this is the example of second order linear differential equations. The general form of second order linear differential equations will be this. Okay, p d square x or d square y by dx square plus qx dy dx plus rxy equals to f of x. Actually, if f of x is not equal to 0, then it is non-homogeneous. And if f of x will be 0, then it will become homogeneous differential equation. Remember it. If the right hand side is non-zero, then it will be inhomogeneous, and if right hand side is 0, then it will become what? Homogeneous differential equation of second order. Second order, why? Highest derivative occurs in this differential equation is 2. Okay, second derivatives. Okay, coefficient. This is the coefficient of first derivatives. Okay, so highest derivatives indicates the order. This is the second order differential equation, and it is non-homogeneous. Why actually? Because right hand side is non-zero. Understand? But if we take f of x equals to 0, then this will become homogeneous differential equation of second order. Remember it. This is the homogeneous differential equation of second order. Actually, general, if we try to understand about the highest order, that means nth order of linear differential equations, ordinary differential equations, of course. Now nth order linear differential equations in any equation of the form p naught p1 p n minus 1 dot dot pn. Actually these are continuous real valued functions. Okay, it's maybe constant also. uh, So p naught and d and dy by dt. Actually, time here actually t is the independent variable, time variable. So there are highest derivatives occurs nth derivatives. Okay, this is why this is the linear differential equation of nth order. And here right hand side gt is the function of t. It is not actually not 0. This is why this is linear differential equation of nth order, but non-homogeneous. So if zt is 0, then it will become homogeneous. And every p naught, p1, p2 up to pn minus 1, and this pn are the constant or function of t only. Remember it. This will be the function of independent variable. Otherwise, this will be not linear. And remember it. The and every p up to p naught to pn, this every p are continuous real valued function of t, real valued function of independent variable. Remember, or constant. Then it will be the linear differential equation of nth order. Remember it. Now we'll try to solve how to we'll try to solve this nth order differential equations using different method. Okay, now we'll try to solve the linear equations with constant coefficients. Actually, this is the nth order differential equations. Capital D is the dy dx here, and this is the homogeneous differential equations of nth order, because right hand side is 0. And these types of equations, if where p1 p2 pn are the all constant or function of x only, then if y equals to e to the power m1x, y equals to e to the power m2x dot dot, how many solutions will be here? N times solution. E to the power y equals to e to the power mnx are the solutions. Okay, because this is the nth order and it will have n solutions. Remember it. If the given differential equation is second order, suppose like this second order, it will have two solutions. Okay, how many solutions will be here? Two solutions. Two solutions. And if we consider nth order differential equations, it will have n solution. This is why y equals to this. How many solution here? Mn. And the general solution can be written as, okay, the general solution will be y equals to c1 y1 c2 y2 c3 y3. That means what? We can write the general solution of the given nth order differential equation like this: y equals to c1 e to the power m1x and plus c2 e to the power m2x plus c3 e to the power m3x. Okay, actually this y equals to e to the power m1x e to the power m2x are the auxiliary equations. Remember it. This name is auxiliary equations. Suppose we'll try to solve this. D square z by dt square plus 5 dz dt plus 6z equals to 0. That means capital D square z plus 5 dz plus 6z. This is also same. Just ddt dz dt means what? Capital D. Understand? Here right hand side is 0. Okay. So let us consider y equal to e to the power mx be the solution of this differential equation. This is the how many order here in this differential equation? Second order, because highest derivative is 2. Understand? So y
Yes,
equals
sir.
to mx with the auxiliary equation. Just introducing this integration. If we take differentiation on both sides, okay, just putting y equals to e to the power mx in the left hand side. D square dz square e to the power mx 5 dy dt e to the power mz plus 6 e to the power mz equals to y. Now this differentiation will be what? With respect to t, m square, right? M square e to the power mz, right? And this will be what? M e to the power mz, and this will be only e to the power mz, only m. So there will be only m square plus 5m plus 6 into e to the power mz, taking common. But it is not possible. It will be not 0. That means it will be non-zero, but the product will be 0 when, so this will be must be 0. Now solving m square plus 5m plus 6 equals to 0, we get what? After factorization method for solving, m equals to minus 2 and 3. So the general solution can be written as c1 e to the power minus twice t. Just putting m equals to minus 2 and minus 3 here. Okay, will be the two solution: e to the power minus twice t and e to the power minus thrice t will be the solution. This is the actually general solution for this second order differential equations. Okay, similar process we can proceed. This is the third order differential equation, right? Third order, d cube y minus 13y minus 12y equals to 0. Let d cube y minus 13y minus 12y equals to 0. So just taking common y. Now introducing e to the power mx will be the auxiliary equation for this. So m cube minus 13m minus 12, and after solving this, because this is not equal to 0, okay, after solving, auxiliary equation will be what? M cube minus 13m minus 12 will be 0. Okay.
Yes, sir.
Just solving m equals to what? -1, -3, -4. There are three roots. Okay, m means actually roots of the differential equation. Remember it. So there are three roots. Why? Actually, this is the third order. If second order, values of m will be 2. If third order, values of m will be what? 3. So the complete or general solution will be y equal to c1 e to the power mx plus c2 e to the power mx plus c3 e to the power mx. First m, second m, third m. That means -1, -3, -4. This is the required solution. Okay. Now for the case 2, actually in first one, case 1, right hand side is 0. Right hand side was 0 and the linear differential equation constant coefficient, and right hand side was actually 0. And for distinct roots, m value what will be? m1, m2, m3 dot all are distinct, different. Okay, all are different. So if we in case 2, auxiliary equation having equal roots. Okay, if there are two roots are equal or three roots equal, then what will be the solution in this case? Now we know that m1, m2 dot dot mn are all different in first case, right? The general solution is was what was y equals to c1 e to the power m1x, it's plus c2 e to the power m2x plus dot dot plus cn e to the power mnx, n times for nth order differential equation. Now, but if we take m1 equals to m2, then what will be happen actually? If m, that means suppose two roots are equal, then what will be the solution in that case? Then it becomes y solution y equals to c1 plus c2 e to the power m1x. Remember it. Okay, c1 plus x into c2. There will be there is a mistake. Please. C1 plus x into c2 e to the power m1x, and this will be the all our rest are same. Okay, we are not proving this actually. There is a proof for you. If you interested, you can prove this. So the solution will be what? C1 plus C2x e to the power m1x, and this is the first roots. Okay, m1 equal roots for these two constant, same values. This is why. So and all are different. Suppose this example, uh, 2 into this is the second order differential equation with respect to x dy dx. That means this will be what? D square y dx square, and this will be dy dx. Y dash means what? Differentiation. Minus 3y equal to 0. Let this can be written as okay like this: 2 d square y by dx square plus 5 dy dx minus 3y equal to 0. Suppose this is the y equals to e to the power mx be the solution of 1. Okay, or m1x, same words. Now 2 m1 square plus 5 m1 minus 3 into y will be 0. Second differentiation, this y m1 square, and first differentiation, so coefficient will be only m1, and there are only minus 3, taking y common equal to 0. So since this is not equal, not non-zero, so it will be must be 0 to make this product 0. Then 2 m1 square minus 5 m1 minus 3 equal to 0. Solving this for how many m here? Minus half and 3. So the general solution what will be actually for this case? C1 into e to the power m1x plus C2 e to the power m2x. Okay, look like previous example. Now let us consider this example. Y double dash, that means double differentiation, second order differential equation of first order, and second order differential equations, and right hand side is 0, so it will be homogeneous. The d square y dx square minus 10 dy dx 25y equals to 0. Suppose this is the auxiliary equation. Okay, y equals to e to the power mx with the solution of this differential equation. So this will be the auxiliary equation will be what? This e to the power mx will be not equal to 0. So m square minus 10m plus 25 will be 0. Solving this, m equals to what? 5, 5. Equal roots here. Remember it. From case 2, we have known that for equal roots, the solution can be written as y equals to c1 plus c2 into x. Okay, e to the power mx. Mx means what? M means what? 5. Understand everybody? Okay, similarly, we can solve this differential equation. second order differential equation. Y equals to e to the power mx be the trial solution for this above differential equation. Then putting y equals to e to the power mx, we get this auxiliary equation will be what? M square minus 6m plus 9. Just solving, we get m equals to what? 3 3. Similar process, we can write the solution. Y will be c1 plus c2 x into e to the power mx. M means what? Only repeated roots. This is for repeated roots from case 2. Remember it. Again solving this is the fourth order. Highest derivatives occurs 4 in this differential equation. So this will be the fourth order homogeneous differential equation, and of course linear differential equations. Okay, so let us consider y equals to e to the power mx be the trial solution. So auxiliary equation will be what? After differentiating and putting these values, uh, m to the power 4 minus m cube minus 9m square minus 11m minus 4 will be 0. But this equations can be written as m plus 1 whole cube into m minus 4 after factorization process. Okay, from this equation we get 4 roots. M equals to what? Minus 1 minus 2 minus 1 minus 1 minus 1 and 4. How many roots here? 4. Repeated how many?
4.
Repeated roots minus 1. Okay, how many repeated? 3 repeated.
3.
This is why the general solution can be written as y equals to c1 plus c2x plus c3x square. Okay, e to the power mx. M means what? Minus 1. Okay, m means minus 1 and plus c4 e to the power m2x other roots. This will be the uh, general solution for this fourth order differential equation. Understand? You have to
See, sir.
remember this. Very important for you this class, because how to represent the repeated roots, how to represent the distinct roots in a solution of a linear constant differential equation. You must remember this. Now for case 3, auxiliary equation having imaginary roots. Try to understand, this will be what? Imaginary roots. Imaginary number will be uh, introduced here. Suppose let us consider alpha plus minus ib, that means imaginary number. Okay, with the imaginary roots of the second order differential equation, then this general solution can be written as actually c1 e to the power mx plus c2 e to the power mx. Okay, second order, for second order differential equation, like this second order differential equation. Understand? The solution can be written as how? Solution can be written c1 e to the power mx plus c2 e to the power mx. Okay, m2x. This is the plus and this is the minus. So we can take common e to the power alpha x, same for both term, and we get this. But e to the power mx or e to the power ix formula, do you know? From trigonometry, e to the power x can be written as cos x plus I sin x, and this also for minus cos x minus I sin x. Okay, from trigonometric properties, relation between complex number and trigonometry, exponential function and trigonometry in complex number, remember it. So then this can be written as c1 plus c2 multiplying, after multiplying the real part, and this is the imaginary part. There are two parts actually. So a equals to, we can write c1 plus c2, and b equals to, we can write imaginary number I into c1 minus c2. That means e to the power alpha x a cos beta x plus b cos beta x. That means the general solution can be represented as, for the complex roots, e to the power alpha x a cos beta x plus b cos beta x. Now we will try it at an example. This solving this example, you will understand better. Now let us consider, this is the second order differential equations. This is actually d square y by dx square, and this will be dy dx, and this is only single y. Suppose y equals to e to the power mx be the trial solution for this differential equation. Okay, so what will be the auxiliary equation? M square plus m plus 1 after differentiating and putting this. Then m square plus m plus 1 will be the auxiliary equation, because this is not 0. Exponential of mx will be non-zero. This why this will be 0 to make this product 0. Now how to solve this? You must know. This is the look like quadratic in m. How? This is the quadratic equation in M. X square plus bx plus c equal to 0. Quadratic equation. Quadratic equation. Second order equation. X square plus bx plus c is called quadratic equation, and this quadratic equation has a solution. X equals to what? Minus b plus minus square root b square minus 4ac divided by twice a. Do you know?
Yes, sir.
Do you know this? X equals to, x means here M. X equals to minus b plus minus square root b square minus 4ac divided by a, twice a. So minus b means what? Coefficient of M, 1. And b square means 1 square minus 4a means what? Coefficient of M square, 1, and c is the constant term, 1. Okay, divided by twice a means 1. 1 comes from coefficient of M square. So the M will give these two roots, and this is the imaginary roots, remember it. Okay, one is positive, other is negative. For plus minus we get two roots from here. Now the general solution can be written as how? Y equals to c1 e to the power mx plus c2 e to the power mx. Now this can be written as minus x by 2 is the common after separating real and imaginary part. E to the power minus x by 2 into e to the power I root 3x by 2. Okay, we get this. Now e to the power minus x by 2 is the common, so c1, this can be written as this, the e to the power ix formula, what? Cos x plus I sin x. Okay, plus c2 cos x plus I sin x. So this y equals to e to the power minus x by 2. This is the real part into cos x, and imaginary part into root 3 by root 3x by 2. This is the actually required solution. Okay, just remember it, minus 1 by 2. Okay, there minus 1 by 2 is the common, right? Minus 1 by
Yes, sir.
minus 1 by 2. So e to the power minus x by 2 is the real part. Another part is I root 3x by 2, right? Root 3x by 2.
Yes, sir.
Understand? Root 3x by 2. Just cos and sine. There are two, will be two constant, because for the second order. This is the second order differential equation. This is why there will be two constant. One is a, another is b, and we will write from this directly from this we can use this solution, not like this. The minus x by 2 will be e to the power minus x by 2 real for common for each term, then root 3x by 2. Okay, cos and sine, and a and b. Types of complex numbers: Cartesian form x plus iy, and in polar form r into cos theta plus I sin theta, and in exponential form r into e to the power I theta. That means cos theta plus I sin theta can be written as e to the power I theta. R is common. Okay. Okay, cos theta plus I sin theta equals to e to the power I theta. Okay, we can prove this. Is z equals to this series, sin z equals to this series, and cos z equals to this series. Combining this two cos z plus I sin z, then we get this. This is the exponential form. Then that means exponential series e to the power iz. E to the power x formula, what? 1 plus x by factorial 1, x square by factorial 2, x cube by factorial 3, like this. Okay, this is the e to the power x formula. So from this we can prove this. Cos z equals to this, and sin z will be what? Just minus and twice y. Remember it. And this is the De Moivre's theorem: cos theta plus I sin theta to the power n equals to cos n theta plus I sin n theta.
Ji, sir.
Okay, e to the power ix, x means what? Root 3x by 2. Okay, e to the power ix equals to cos x plus I sin x. Just separating real and imaginary part on, then we get this. Now solving another problem. Hello,
Ji, sir.
একটু ডিস্টার্ব হয়ে গেছে।
Ji, sir.
তাহলে there are actually how many roots? 4 roots. Okay, one is for m square plus 3 and other is for m square plus 2. 4 roots because this is fourth order differential equation. Fourth order differential equation. There will be m square equal to minus 3 and minus 2. So m equals to what will be? Minus 1 equals to what? I square for imaginary number. I equals to root over minus 1. So I equals to minus 1 equal to I square. This is why m equals to what will be? Root 3 root over 3 I plus minus root over 3 I. Another will be plus minus root over twice I. Okay. The complete solution will be for the given differential equation of fourth order will be a constant into cos root 3x plus b into sine root twice x. Okay, this is the root twice x and this is the root 3x. This can be written as also like this.